All right, I'm going to go through 2013 number 4 now. A lot of skills that we've been practicing, but different ones than number 3. So I thought this was another good one to get a variety. So they give this picture. It is a derivative picture. So you know there's going to be some sort of curve analysis when you're given a derivative graph. Since it's not geometric shapes, they actually tell you the areas that are under the curve. I made a little note with this one that's underneath. The area is 3, but when I work with integrals, I need to think of it as negative. So it tells us a lot of things about where it has horizontal tangent lines. All that's telling us is where it has those minimums and maximums on the derivative graph. It tells us where the area is located. And then it tells us that we know f of 8 equals 4, and we'll use that later. So part A wants to know, is there a place, or where is the place in that interval from 0 to 8 where it has, the original function has a minimum? So when you're doing a curve analysis and you're trying to find a minimum or a maximum, you're looking to see when the derivative shifts locations. So if it goes from above to below or below to above. To get a minimum, you need something that decreases and then increases. So visually what you're looking for on your derivative graph is where does it go from below the x-axis to above the x-axis? And that happens right here. So here's what I wrote down. I wrote down that f would have a minimum at 6 because at 6, that's where the derivative has a sign change from negative to positive. Make sure you're specific when you say what's changing signs. And again, in this case, it's the first derivative. For points, they gave just 1 point for that. If you said 6 and you had a decent justification, you got that point. Part B wanted to know the absolute minimum. When you're looking for an absolute minimum of an interval, not only are you checking any critical value, any place that it has a relative minimum or maximum, but you also want to check the endpoints because the highest point in an interval or the lowest point in the interval could be at the beginning or the end. I like to think of these as table questions. So first thing I wrote down is I kind of listed what are all my potential places where this could happen. Well, I have critical values at 1, at 4, and at 6, and those are all the places where my derivative equals 0, 1, 4, and 6. And the other thing is my endpoints are 0 and 8. So those are all I like my contenders, my possibilities. So I put them in my chart, although you'll notice I didn't do a ton of work for some of them. Like, for example, number 1, or at x equals 1, I know that doesn't end up being an extrema because it doesn't change locations. It stays above the x-axis, which means the derivative's positive and stays positive. So I actually tossed that one out pretty quickly. I also tossed out at 4. And the reason I'm tossing out 4 is I know 4 ends up being a maximum because my derivative goes from positive to negative. I can see the pictures above to below. So those two are not possible. The other thing that I know is I know what happens when I put 8 in, I get 4. Here is the given information that I hadn't used yet. So f of 8 equals 4. So those 3 things I filled in my table quickly. The other 2 take some work. I need to figure out what happens when x is 0 and what happens when x is 6. So to do that, I'm going to set up an interval. Now, I'm going with 0 as a boundary because that's what I'm trying to figure out when x is 0. And the reason I'm making 8 be a boundary is I know what happens at f of 8. That's that given information again. So I'm setting up like a fundamental theorem of calculus. If I integrate from 0 to 8 of f prime, I'm going to get the original f, and it's going to be top minus bottom. The integral from 0 to 8 comes from these intervals, these area. So from 0 to 8, I have an area of 2, an area of 6, an area of 3 that's underneath, so a negative 3, and an area of 7. So I added the 2, the 6, and the 7 and subtracted 3. That's where I got this answer of 12. F of 8, you're told in the beginning is 4, so I filled that in. F of 0 is what you're looking for. So I put minus f of 0. I subtracted 4 to the other side, giving me 8, but then I divide by a negative to get f of 0 by itself. I get negative 8. So that's my y value when x is 0. And then I did the same thing for 6. Now for 6, again, I know what 8 is happening at f, so I made that still my upper boundary. I now need to figure out what's happening at f of 6. So I wrote an integral again, integrating f prime. I get f of 8 minus f of 6, top minus bottom. From 6 to 8, again, this is very visual. So from 6 to 8 is this last piece right here. And that they told us had an area of 7. So that's where that 7 is coming from in my work. And then f of 8 again was given as 4 minus f of 6. That's what I'm solving for. Let me move myself a little bit higher here. So I'm going to subtract 4 from both sides, divide by a negative 1. I get negative 3. Now, it wants the absolute minimum, which is the lowest y value. They're actually referring to the y value when they ask for a minimum or a maximum. So my absolute minimum, my answer I kind of wrote in the middle, is negative 8, and that happens at f of 0. That happens at x equals 0. So for their scoring, they gave a lot of points for this just because there's a lot going on here. They do want you to consider 0. They do want you to consider 6. I considered a lot more than that, but as long as you consider 0 and 6, you get a point. And then my answer is -8. My justification, it can be done a lot of ways. I think a table organizes it well, so that was my justification. They did it kind of as a list, and they looked at the different possibilities to figure out. And again, it's the possibilities that we talked about. The couple things I put in my table that I tossed, they didn't even mention, which is fine. That was just kind of me organizing my thoughts. And then Part C wanted to know when is the original function concave down and increasing in that interval. So I actually did my work up here. Move myself again. So I wrote a little note like, what does it mean to be concave down? What does it mean to be increasing? Concave down means my second derivative has to be less than 0, negative second derivative. Increasing means my first derivative has to be bigger than 0. I actually started with that thought. Increasing derivative greater than 0 means that this picture would have to be when the graph is above the x-axis, because this is a graph of f prime. So I'm looking at everything here from 0 until we get here at 1, 2, 3, 4, and then again from 6 to 8. So those are my potential because those are increasing. And then concave down means my second derivative is negative. That means in this graph, I'm looking for a negative slope because the derivative of this derivative would be that second derivative. So I'm looking to see when is it above the x-axis and having a downward slope or decreasing. And that happens at the beginning from 0 to 1, and then it happens again from from 3 to 4, and that's it. And you're just listing them as x intervals. So I wrote them like this. I think they wrote them with less than signs. And then my justification is really, what am I looking for? I'm looking for a positive first derivative and a negative second derivative. So for scoring, they gave 2 points, one for your answer, and your answer is between 0 and 1 and 3 and 4, and you could write it like they did or like I did. And then your explanation can be as simple as what are the signs of what you're looking for. And then finally, Part D wanted to know. Part D, I like Part D because it's just totally different. You're not really using the picture at all. A little bit. I guess I used the picture for a very small piece. It was asking you to derive this g function and figure out the slope of g at 3. So when I derive it, it's a chain rule. It's kind of like a semi-generic chain rule. So power out front, power 1 less, derivative of what's inside. I'm putting 3 in. Now they tell you that f of 3 is -5/2. So if you were looking at this going, what do I put there? You're going to put your -5/2. That's going to have to be squared. It's going to have to be multiplied by 3. You're also going to have to multiply by the derivative of f at 3. This is the only time you'll use this table. It's very minor. The derivative, this is a derivative graph. The derivative of f at 3 is 4. It's the y value that goes with that point. So you're going to take 3 times the -5/2 being squared times a 4, and you get 75. So for the scoring, they gave 2 points for the chain rule, which is pretty generous. So you're going through, the biggest thing that students tend to forget is the derivative of what's inside. And then you get 1 point for your final answer of 75, no matter how much work you showed. So again, 9 points. See how you're doing, give you a chance to practice maybe some skills that you feel like you needed to brush up on. And if there's other things you need or more questions, let me know. I'm going to continue to search to see if I can find some other optional ones out there. Have a great day, guys.